In this chapter and in the coming lectures, we are going to talk about recursion, but in order to understand recursion, first we have to understand memory management, we have to understand the stack memory and so on. But first of all, let's understand what is happening exactly under the hood when we run a given application. So first of all, we have to create the source code of the application. Then, whenever we compile the application, then the machine level binary code is generated, which is in binary. Whenever we would like to execute our compiled application, so essentially we would like to run the application, then the generated machine level binary code must be loaded into memory. Of course, because the local variables, the global variables, the method calls must be stored in the memory. Okay, so this is why the application must be loaded into the memory, and the random access memory is a memory region that is used to run applications. By the way, it has three parts. First of all, the machine code. So this is where the code of our application is located. Then we have the stack memory and the heap memory. These are the memory regions that are used by our application. Of course, because let's assume that we would like to download some data from the web and we would like to process that given data. Of course, we need some data structure in order to store the data we have downloaded. And there are two options. We can store these items in the stack memory or in the heap memory. So this is why it is crucial to understand the differences between these two types of memory. Okay, so first of all, let's talk about the stack memory. The stack memory is a special region in the random access memory. What's crucial that it is a special data type, essentially a stack abstract data type. This is why it is connected to the stack abstract data type that we are talking about. And it stores local variables as well as method calls. So for example, on the left, you can see the illustration of the tic-tac-toe game with the help of the minimax algorithm. Essentially, minimax algorithm is a recursively implemented depth-first search. What's important that essentially we keep calling the same method over and over again. And as you can see, the stack is going to track these independent method calls. So every time we call a given method, then there's going to be a new stack frame inserted into the stack memory, and the given stack frame includes all the information we need, such as the local variables. Essentially, this is how the programming language knows where to return after finish execution of a given method. So whenever the recursive method is executed, then essentially the programming language removes the last stack frame from the stack memory and backtracks to the previous one. And of course, with the help of the stack memory, the programming language knows where to return after finishing the execution of a given method. By the way, it is small in size but fast to access. So we are not able to store a huge amount of items or objects in the stack memory, but we can access these items extremely fast. And what's crucial that it cannot become fragmented, in the sense that these stack frames are removed automatically by the operating system whenever a method is executed and the given programming language backtracks to the previous method call. Okay, by the way, you may guess that if there are a huge number of stack frames that cannot fit into the stack memory, then there is a so-called stack overflow error, which means that the large amount of stack frames cannot be handled by the stack memory. And of course, it can happen because the stack memory is small in size. This is what we have discussed a few minutes earlier. What about heap memory? Heap memory is a special region in the random access memory again, where dynamic memory allocation takes place. If you are familiar with the C programming language, this is the typical malloc function or realloc function. This is how we can allocate memory on the heap memory. What's crucial that the size of the heap is way larger than the size of the stack memory. So this is why if we are dealing with a huge data set or large amount of objects, we have to store these items on the heap memory. Okay, so objects and reference types are stored on the heap memory. We are going to talk about it in the next lecture, that essentially whenever we instantiate a new object in Python, then the given object is stored on the heap memory, but there is a reference that is stored on the stack memory pointing to that given object on the heap memory. Okay, this is what we are going to talk about in the next lecture. What's crucial, that heap memory is large in size but slow to access, so we can store a huge amount of items and objects on the heap memory, but in order to access these items, it takes some time, so it is slower than stack memory. And finally, the main disadvantage is that it can become fragmented, in the sense that, for example, if we are using the C programming language, we have to make sure that we free up the memory space that we have allocated earlier when we do not need a given object anymore. By the way, in Java, there is the Java virtual machine that's going to run the so-called garbage collection, and the garbage collection procedure is going to remove unused objects from the heap memory. But what's crucial, that the heap memory can become fragmented. For example, when we create a huge amount of objects, this is exactly what has happened to me when I have developed a game from scratch. Of course, as you can see, there is a huge amount of objects such as rockets, such as enemy ships. Of course, we have to make sure that we are not going to use more memory than necessary. So we can have a heap memory overflow if we allocate memory without deallocating previously allocated memory space, or if we allocate an extremely large number of objects. And by the way, this is why there are extremely good design patterns for game development, in order to reuse the objects we have already created. That's all about stack memories and heap memories. Thanks for watching.